So I will rewrite the formula though, because I need to keep that in mind. B times IL over A plus B, and IB is equal to IL minus IA. Right. Now let's draw another scenario. We'll have a fuse board here. This time we want some different lengths. Let's go with one there, one there, one there. Now I want this length to be short. This is 3 meters. I want this length to be long, 20 meters. We'll call this one 5. You can see I'm making this up as I go along. This one could be 12. I want a number I can actually count up to though. So we'll go with 10. That's 10, so let's call that 8. 20, 30, 42, 50, 5, 6, 7, 8. Alright, I'm going to write down, just down here, 58 meters. Because I'll keep forgetting that. That is the length of A and B. Basically, wherever I am, that's the overall length of the ring final circuit. I need some loads. Let's put some loads in. We'll put them in red. We'll go with 10 amp. Let's go higher here, 12 amp. We'll go smaller here, 3 amp. 10 amp up here. And 8. So we've got to crunch this one through. Oops. We'll start with this one. We'll call this socket 1, 2, and 3, and 4, and 5. So start with socket 1. So socket 1 equals IA equals B times IL. Well, we know B is now 58 meters times IL, which is 10 amp plugged into it, over A and B. Actually, B isn't 58 meters because B is 38 meters. Let me just do it again. Alright, 38 meters is B, because B is the... Let me draw B in actually. In this example, this is A, 20 meters, and this is B, which is obviously 58 meters minus that 20, which is 38 meters. Okay, so that's B, and that's A. Just remind you of that in case you've forgotten that one. I'll just delete those though to make it fairly easy to read. So 38 meters for B times IL plugged into it is 10 over the A and B, which is the 58. So that is 380 over 58, which I have not got a clue. What was it? It was 380 over 58. 380 over 58 is 6.55. Okay. So we'll call that 6.55 amp. So that means of this 10 amp load here, there is 6.55 amp going that way. And if there's 6.55 amp going that way, then I'll get the calculator back. 10 minus 6.55 is going to be 3.45. Then that means there's 3.45 going that way around the ring. So let's do this up here. socket 1 equals 6.55, 3.45, and that's the IA and that's the IB. Okay, that's the first socket worked out. Let's now go to socket 2, 12 amp. So before I confuse the issue, we'll delete that working out. I do wish that eraser would stay on. We'll just do socket 2 next. So socket 2 is equal to, well, in this case, B has been shrunk because it's not that 5 meters anymore. So B is going to be 12, 22, 33 meters times the IL of 12 amp plugged into it over the overall length of 58 meters. So that's 33 times 12, which is 390, I believe. Okay, I can't work out. 396, yep. Over 58. 6.83. All right. 6.83 amps. So we have, of this 12 amp, we have 6.83 going that way, and that kind of makes sense because that is the shorter route back. That's 25 meters that way. This way is 22, 33 meters. So yeah, it makes sense for a bit more of the amperage. Bit more of the amperage to go that way. That's 25 meters. That's 33 meters. So yeah, a little bit more current should go that way. So if 6.83 is going that way, 12 minus 6.83, that means 5.17 is going that way. Okie dokie. So socket 2 equals 6.83 IA and 5.17 IB. Right, we're making progress. Now let's just get through these last ones. Start with socket 3. Just a 3 amp. Okay, so that's 10, 18, 19, 20, 21 meters. So B is 21 times 3 over 58, which is 63 over 58. This is obviously going to be a very low share. 63 over 58, 1.09. So of this 3 amp, 1.09 of it is going that way. And 3 minus 1.09 is 1.91. I should really spend more time than working out myself. I can't be asked. And 1.91 of that is going that way. And if you think about that, yeah, well, more amps are going that way round because it's a shorter run, 10, 18, 21, compared to this longer run. So we have a 1.09 and a 1.91. Socket 3. Let's go to socket 4. Delete, 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 delete. Oh, you bastard. Socket 4. Socket 4 is 8 amp. So we have 11 meters, so B is 11 times 8 over 58. Because 58 is, remember, the overall length. Which is going to be 88. Please, yeah. 88 over 58, which is 88 over 58 bring this over here so you can see it. Is 1.517, so 1.52. So that means of this 8 amp here, 1.52 amp of that is the IA. And so if 1.52 of that is IA, then 8 minus 1.52 is 6.48. Yeah, obviously. 6.48 of that going that way is IB. Okay, hopefully you can see now, as this 8 amp socket is so much closer to this side, a lot more of its current is being shared that way. Okay, so it's always a bad idea to assume that a socket outlet will share the power evenly. It all depends on where it is in its proximity to the consumer unit. Right, let's just quickly go through the 5th socket. Fifth socket is 10 amp, so socket 5 is 10 amp. That's going to be a B of, well, the B is only 3 meters there. The B is that way, 3 meters. So 3 times 10 over 58, which is 30 over 58, which is, well, of that 10 amp, 30 over 58, only 0.52 amps of that. 0.52 amps of that are going this way. That's socket 5. Alright, so if 0.52 amps that must mean, as I do it here to verify anyway, 10 minus 0.52, a whopping 9.48 of that. 9.48 amp of that 10 amp load is going that way in that 3 meter cable. So, you know, they do not share equally, depending on where they are around the ring final. Okay, so now we've got that information, what can we do? We can now, if I need to tidy this up. Let's tie this up. We don't need that working out anymore. What I now want to try and work out is the current on each of these legs. So let's label these legs. Leg 1, 2, 3, 4, 5, 6. Remember, the whole point of this was to ensure that the leg for sustained periods of time will not be more than 20 amps. So we need to hopefully get less than or equal to 20 on each of these legs. And if we get over 20, we've got to assume whether or not the load can be a load of long duration. But let's figure out if any of these loads are going to go over 20. Right, so the first thing I want to do is, let me get this calculator out of the way, is I want to quantify the legs. I will start here with leg 1. Now leg 1 is this cable here. Okay, let me just check on OBS to make sure you're seeing that. Yes, you are, excellent. Right, so this cable here is only going to be carrying the current that this is pulling that way, the IA. This is pulling that way, the IA. This one is pulling that way, the IA. So it's all the IAs. I want to add the IAs together. And that's what I'm going to do. So it's 6.55 plus 6.83 plus 1.09 plus 1.52 plus 0.52. That gives me an overall amount of current on this leg of the ring final. Let's get the calculator in. So, forgetting what the math was, I can see it there. I can see it right there. So 6.55 plus 6.83 plus 1.09 plus 1.52 plus 0.52. 16.51. Alright, move that out of the way. So this leg has 16.51 amps on it. Let's write that there, shall we? 16.51 amps on that leg. Happy days. Leg 2. I'll get this, I'll do the calculation in a minute. Now, before we get ahead of ourselves, with leg 2, we need to now notice that this is this cable. This cable was the IA of this one going that way, and the IA of this one going that way, and so on. This cable, however, is not subjected to the IA of this load. It's subjected to the IB of this load. So I'm going to take the IB of socket 1, which is 3.45, because it's going that way for leg 2. But now I'm going to take all the IAs again. So I'm going to repeat, I'm just going to copy this here. So plus 6.83 plus 1.09 plus 1.52 plus 0.52, because all of those are the IAs going this way through that leg of cable. Okay, crush that. Alright, so I'll put it here. I'm going to copy 3.45, but then I'm going to copy the IAs for the remainder. So 3.45 plus 6.83 plus 1.09 plus 1.52 plus 0.52 equals 13.41. Alright, so we have 13.41 amps, which is here, 13.41 in that leg. Let's do leg 3. Leg 3. Now with leg 3, it's going to have the IB of this socket pulling that way, and the IB of socket 2 now pulling that way. So we're going to take the IBs of sockets 1 and 2, but then the IAs of 3, 4 and 5. Okay, so hopefully you understand that. So I'm going to go with 3.45 plus 5.17 plus 1.09 plus 1.52 plus 0.52. Okay, so the IBs of that socket and that socket, but the IAs of that socket and that socket and that socket, because those are all pulling current through this leg, leg 3. That's what I'm trying to achieve here. So where's my calculator gone? Oh, there it is, right. So we're going to go with 3.45 plus 5.17 plus 1.09, so we're coming across to the IAs now, plus 1.52 plus 0.52 is 11.75. So 11.75 amps, and that tells me, okay, in the red there, that this leg here has 11.75 amps on it. Alright, leg 4. Squeeze this in the bottom here. Now leg 4, calculate out of the way, is going to have the IB of this socket pulling that way, the IB of this, and the IB of socket 3, the IAs of 4 and 5. So it's going to be 3.45 plus 5.17 plus 1.91, because I'm moving over now to the IB column. Okay, plus 1.52 and plus 0.52. So of that, the 1.52 and the 0.52 are the fact that this cable is pulling that way. Sorry, this socket and this load is pulling that way, because I'm doing this leg, but these three are going that way around. Alright. Isn't this fun? Alright, so 3.45 plus 5.17 plus 1.91 plus 1.52 plus 0.52. 12.57 amps. We get 12.57 amps. And that is there. On leg 4. I'm running out of room. Let's do leg 5 up here. Now leg 5 is going to be subjected to, where's my calculator? There's my calculator there. Okay, I'm going to have the IBs all the way down to 6.48 because that's this way. So socket A is pulling this way. Socket 1, socket 2, socket 3 and socket 4 are all pulling this way. Only socket 5 is pulling this way. So I'm going to use all the IBs except for the last one where I'll still use 0.52. So 3.45 plus 5.17 plus 1.91 plus 6.48 plus 0.52. Okay. 3.45 plus 5.17 plus 1.91 plus 6.48 plus 0.52 equals 17.53. So I have 17.53 amp on leg 5. Last one. Leg 6. Now leg 6 is this one, and that's pulling this IB now, as well as this IB, as well as this IB, and you can see I'm just going to add the IB column. That's all I'm going to do. I don't need the IAs. In no way is leg 6 subjected to any current going this way from any socket outlet. So let's add them together. So 3.45 plus 5.17 plus 1.91 plus 6.48 plus now 9.48. Okay. Where is it? There it goes. Right. So 3.45 plus 5.17 plus 1.91 plus 6.48 plus, to finish off, 9.48. And we get 26.49. Alright. And that is 26.49 amps on this leg here. Now that is a concern because any leg of the ring final should not be subjected to a current beyond 20 amp unless maybe the cable is sized to accommodate that. So the next question would be the loads, maybe, you know, this one and this one, probably not this one, but these loads here that are obviously putting a larger power demand that results in this IB of 9.48 amps is creating a much larger amount of current on this leg than any other leg. Are these loads subjected to long duration? If they are, then it needs to be rejigged or it needs to be sorted out so that they are not on this circuit, because this is a scenario that we really don't want and the regulations really don't want us to have. Wow. Let me just check something. Yeah, I thought my head would be in the way with that. I haven't got the OBS out, I now do. There's the math now that my head's out of the way. So in this video we have at length gone through how to understand how the current is shared around the ring final. When you do it like this, it's a very, very it's a very lengthy process with numbers, but you know, it's a fairly simple formula. All right, it's fairly simple. Have a go at it. You know, make some circuits up, have a little play with it, and understand how it's really important that these legs, especially these short ones, yeah, that they are not connected to larger loads that are on for long duration, because they will not share the power around the ring final. All right, in the middle of the circuit around here, these ones will share better. They'll have a much lower capacity. You can see here 11 and 12 and 13. But when we get nearer the incomer or nearer the main board, yeah, this is a 20 meter cable, so that's not so bad. But this little 3 meter cable, everything you plug near that's going straight down that cable. It will not share around the ring final. All right, guys. Looking back at this, I'm thinking, crikey. I hope that came across okay. If not, I'll have a, I can try and make it a little bit easier. But if you want me to go through some more of those, just let me know. But this is something that I do on the design course. I also just show the guys the whole. Just so you know, if you're doing cable calcs with ring finals, you want to make sure that when you're coming to your IN over CA, CI, CC, CG, all that, use 20 amp. Okay, that's the value. That needs to go over the rating factors. All right, when we're doing cable calculations. So do make sure that you remember that with the ring finals. All right, yeah. See ya.